In arid regions, firewood has always been a luxury. Deserts punish anyone who assumes fuel will be available on demand. Long before modern stoves or bottled gas, desert nomads, caravan traders and military scouts developed a fire pit system that functioned almost entirely without wood. This was not a mythic trick or a one-off improvisation. It was a repeatable, reliable method designed for environments where vegetation was scarce, wind was constant, and visibility mattered. Over time, this desert fire pit fell out of common knowledge, replaced by fuel-dependent solutions. Yet the logic behind it remains sound and surprisingly effective. The fire pit relied on heat retention rather than flame size. The defining feature of the lost desert fire pit was its focus on retaining heat rather than producing large flames. Instead of building upward, it was built downward. A shallow pit was dug into compacted earth or sand, just deep enough to shield embers from wind while keeping airflow controlled. The pit walls acted as insulation. Earth absorbs and reflects heat far better than open air. By concentrating heat in a confined space, even minimal fuel sources could generate usable warmth for cooking or heating hands during cold desert nights. For modern application, this means resisting the instinct to build tall fires. Depth and containment matter more than spectacle. In deserts where trees do not grow, animals still travel. Camel, goat, sheep, and even horse dung was a primary fuel source. When dried, dung burns slowly and steadily with a surprising heat output. Desert cultures understood that fresh dung was useless. It had to be dried thoroughly under the sun until all the moisture was gone. Once dry, it became lightweight, odourless, and easy to ignite with just a small ember. During caravan travel, dried dung was often collected along routes and stored for later use. This practice allowed long journeys without dependence on wood. Today, while dung fuel may be unfamiliar to many, the principle applies to any dense organic matter that can dry fully and burn slowly. The pit design minimized smoke and visibility. You see, smoke attracts attention and wastes heat. The desert fire pit was shaped to limit oxygen intake just enough to sustain combustion without excessive smoke. Fuel was placed low and, once ignited, partially covered with sand or flat stones to regulate airflow. This produced a low, steady burn rather than open flame. The result was a heat source that could cook flatbreads, warm water, or provide comfort without revealing position from miles away. For survival scenarios where discretion matters, controlling smoke output is as important as generating heat. One of the most efficient uses of the desert fire pit involved stones. Once the pit reached sufficient temperature, dense stones were placed directly into the embers. These stones absorbed heat quickly and retained it long after fuel was exhausted. The stones could then be used for cooking by placing food nearby, or for warmth by arranging them in sheltered areas. This reduced the need for constant fuel feeding. Modern users can apply this by selecting dense, dry stones and, avoiding porous rocks that may crack when heated. Sand played a dual role. It insulated the pit and regulated oxygen. By partially covering burning material, sand slowed combustion while trapping heat below the surface. In some cases, food was cooked directly in the sand using retained heat rather than open fire. This technique required patience and, honestly, a solid understanding of heat behavior, but it conserved fuel and avoided flame entirely. This method remains viable today for low-visibility cooking when fuel is limited. Now, desserts are not always hot. At night, temperatures can drop sharply. The recessed fire pit reduced wind exposure, allowing even small heat sources to remain effective. Travellers often slept near the pit after fuel was spent, benefiting from residual warmth in the earth. The ground itself became a thermal reservoir. This approach highlights a key survival lesson. Terrain can be part of your equipment if used correctly. As fuel became portable and cheap, knowledge tied to scarcity faded. Bottled gas, metal stoves, and imported firewood replaced local solutions. Over time, the desert fire pit became associated with hardship rather than efficiency. Yet, in true low-resource environments, modern tools fail quickly. Batteries drain, fuel runs out. What remains is understanding. This pit did not rely on technology. It relied on observation and restraint. To use this method now, you'll want to begin by selecting a sheltered location away from loose sand that might collapse. Then dig a shallow pit with firm sides. Next, collect dry organic fuel, whether that's dung, plant matter, or compacted debris. Finally, ignite with minimal tinder. Once it's burning, regulate airflow using sand or stones. If stones are available, heat those as well. Rely on the retained heat rather than a constant flame. Just allow the earth to do the work. This is not a fast method. It's an efficient one. The Lost Desert Fire Pit worked because it accepted environmental limits instead of, fighting them. It did not demand wood where none existed. It did not chase flames when heat was the goal. That mindset really is what separates sustainable survival from wasteful struggle. If this guide expanded your understanding of how past cultures mastered hostile environments with simple, repeatable methods, then subscribe to Backyard Wisdom, share this episode with others who value practical history, and help keep knowledge alive that still works when conditions are unforgiving.